well, now, if I've got my numbers right and my buttons right, and I'm looking at my slider and there's imagery before my very eyes, then we should be live for Rail Natter. Everyone, hello. It's not that delayed a start. Just a minute. I do apologise. Yes, everyone, it's Rail Natter. It's episode 166. 2 half-forgotten but important railway crashes from the 1980s. Yeah, every now and then, partly for a bit of hashtag content, but partly because I think it's interesting to pick through them, and partly because I think it's quite instructive to look over things the railway has got wrong in the past. We're going to have a look through. It's one crash report, but it covers 2 crashes today, because that's how we learn, right? Hello, everyone. The other thing which we're going to do is we're not going to do the news. No, there is sound. Oh, a quick question. So I was looking through some of the reviews on Apple Podcasts, which has been quite instructive. Thanks to all those who've left reviews. If you haven't, please feel free to. It makes the podcast more popular. One of them was that the intro music is too. That is the balance. Is the sound? I've been listening back and it doesn't sound too. And I don't think it sounds too bad. But what are your thoughts on sound balance, on sound level, noise level of the intro music compared to me voice? Thoughts on a postcard. If you're not sure, well, listen in this episode and tell me. Change it for next time. Anyway, of course, episode 166 means we must give thanks for the class 166. We're into the multiple units now, so we've got our episodes are going to have all sorts of affiliations now. Here is a 166 taken pretty much a photo taken from pretty much the same spot as the 165 from the previous episode. Here it is, 3-car 166 looking decidedly underwhelming, but yeah, this train has a lot to answer for. The future of our DMUs is was being founded here by the network of turbos. People are saying it's generally fine. Yeah, there we go. Right, that's all there is really. Let's get on with it. It's going to be a tight episode, this one, in theory. Let's see what happens, shall we? Anyway, let's crack on. Welcome to tonight's show, everyone. City 225 fades away. There's no news this week because I'm going to do a news wrap up next week, because there's a few things I want to dig into a bit more detail about. So all that remains really is for me to crack into into content warning, just to say, look, there are going to be descriptions and images from rail crashes in this episode. It's worth stating that no one was seriously injured in these crashes. But that doesn't make them any less triggering and unpleasant for people who've perhaps been in a crash or find the idea of crashes pretty horrifying. So just a bit of a content warning. We're going to be going through crash reports. So, on the subject, before we do that, before we look at said crash reports, we must first talk about fish plates. What's a fish plate? We're going to talk about what a fish plate is. That's what we're doing now. I was indeed channeling Quaalude's Acaster there. Yes, we're going to talk about what a fish plate is, because it's an important bit of prior knowledge to this episode. Interesting. Rob Brewer, just as last week's episode 165 was heralded by a 165 passing my flat, this week 1662054 forms a slightly delayed 2 kilo 54 to Severn Beach. Thanks, Rob. That's nice. That's a bit weird. I don't know what's going to happen next week. Who knows? Anyway, right. What is a fish plate? A fish plate is a thing that connects to. Yeah, let's get my little face in there. It's me. I'm in the corner. Hello, everyone. Yes. What is a fish plate? A fish plate is. It's this thing here. Oh, no. Click here. Press Control P. And circle this like that. Well, that's no good. Let's get a bright colour, because that's just a waste of time. Let's get a nice bright yellow. There we go. Press E to clear. There's a fish plate. There's a fish plate. There's a fish plate as well. Now, this picture is actually a feast for the P-Way nerds among you, because these are CS3 fastenings, post-pandrel, non-pandrel fastenings for the real nerds out there. SHC hoop clips with an elastic fastening here, with a steel plate that goes in here, hooked through a a sleeper that we went through all the history of sleepers, didn't we? Well, the SHC sleeper is in amongst all this, and you can see, this is not relevant to fish plates, by the way. I've just gone off on one. You can see the hook. There's the hook, the hoop here, and then there's another hoop here, and the plate. In theory, this gives you a nice elastic sort of connection, but the reality is that fitting these is an absolute pig and a nightmare. And so, even though there's SHCs across the whole country, they're an absolute. We try to get rid of them wherever we can. Oh my God, Alexander Roderick, you stopped the freshly released WTYP halfway through to come see this live. Alexander, that's dedication. Points, prizes. Anyway, right, I digress. So there's all sorts of other things. There's some bonding that's been cut. So there's some bonding cables here to make the track circuit work, except that they've been cut. Now, let me just show you what it would be a little metal cable that would connect like that, and then another one that would connect up like that. To make the just in case this, I mean, you could this transfers a circuit, this joint, but just in case it didn't, there's a backup little kind of bit of bonding there to add to make sure that you definitely maintain your track circuits. Anyway, I digress. Also, you can see there's some horrible sort of P ballast that they've used. Does anyone know where this is, by the way? Anyone know where this is? Yeah. Campaign for North East Rail is saying, why is it called a fish plate? Is it another example of nautical terms making up most of the English language? Goddamn. That's a good question. We have a possible way to find out the answer to that. There he is. Let's get Ellis out. Here we go. It's a good question. Oh, should we get desk cam up to find this out? Right, here's desk cam. Here is Ellis's Railway Encyclopedia. Very good, useful reference guide. What Easter eggs are there in that thing other than my watch, a packet of dried apricots, fish plate? Let's see what it says. Fish plate here. What the official definition of fish plate is, because that's a good question. Let me remember what this floater. Yeah, it's always good. FL, no. FIX, no. FIS, fish bolt, no. Fish plate, see fish plate, okay. Fish bolt hole, finished fishing, fish plate, there we are. Now, is it going to give us the... here we are. Here we have the definition. So, if I hold this up to you, fish plate is there, there's fish plate, there. It's there. That's the definition, and I shall read it to you. I shall read it to you now. We have fish plate, permanent way. Specially rolled or forged steel plates used in pairs to join two rails at a fish-plated rail joint. 2, 4, or 6 fish bolts are used through the fish plates and rail ends to secure the fish plates to the rail ends. There are many possible origins for the name. Here we are. So this is the bit that you're asking for. I shall continue using your YouTube name rather than who it actually is, since I know who it is. Campaign for North East Rail. 3 possible options. From the Old French, fiche, meaning peg, combined with plate, literally a peg plate. That seems plausible. From the fish-like shape of early fish plates, also plausible, because they've got a bow bottom, a bit like what the deep-skirted ones we're about to talk about do, actually. And then, according to John Wolfe Barry, from the nautical practice of fishing, meaning to splint a broken mast. So there you go. There are the three different meanings. So I quite like those. See also, this is true P-way style. See also, cranked fish plate, deep skirted fish plate, emergency clamp fish plate, encapsulated fish plate, insulated fish plate, jump fish plate, junction lift fish plate, junction fish plate, lift fish plate, skirted fish plate, stepped fish plate, straight fish plate, tight joint fish plate. See also William Bridges Adams random. Okay. Anyway, thank you, Ellis, for your encyclopedia of joy, giving us all the information we need. Let's put that back on the shelf. Oh, incidentally, while we're here, look at this. This is an original London Midland Region £109 Switches and Crossings book. Look at this. Look at this. Isn't it gorgeous? That at some point we have to dig into. Anyway, I digress horribly. Sorry. I had this behind me from Rail Matters, and then I replaced it with... It was falling down and getting damaged, so I wanted to put it flat. I replaced it with beaching, anyway. Yes, the klaxon did just go off. Anywho. Oh, right, I digress. What is a fish plate? Well, that was the wordy definition of a fish plate. But if I jump back, a fish plate, physical fish plate. We're looking at P ballast. We're looking at the mess. This is Redmar. This is up at Redmar, by the way. Anyway, I digress. So, a fish plate. Here it is. These are the fish bolts. In this case, we've got 4 hole. So it's 4 fish bolts here going through a fish plate. The fish plate is this thing. It's this thing here. There's one, and there's another one on the other side here, and there's another one up here. There we go. And there's another one on the other side here. And you can see that it has, in this case, it is a 4-hole fish plate. Pretty standard. Again, you've got 4 holes here in behind the bolts. And you can see that it connects up to the end of the rail here. In this case, we have 2 flat bottom rails. So they're flat bottom because you've got the rail head here, which is a kind of a roundish shape. Actually, it's, if I clear all that, the head of the rail kind of looks like that. And then it's got this shape here like this. And then goes back, and then it's up, and then it kind of looks like that. And that's kind of the section of the rail. That's kind of what the rail section looks like in if you took a slice. Well, you don't need to take a slice. If you took the slice here through this bit here, there we are. Actually, I can draw it because that goes like that, and then it goes like that behind the fish plate, and then it goes like that, except drawn better, kind of like that. Anyway. So we have, this is flat bottom rail, this is 18-288 length panels. Someone asked about getting rid of fish plates and they added my name. Gareth, was it you? I'll come back and find it in a second. Here are 2 fish plates. This is on flat bottom rails, which means that you haven't really got, the space you've got to put a fish plate is pretty restricted. So, but the bending strength of rails is better, so they don't dip as badly anyway. So it's a more robust joint in the first place. These bad things have happened here because this has become tight jointed, probably from rail creep, which means it's no longer behaving as a dynamic system that a fish plate, that a kind of a fish plated joint should. Each of these are expansion joints. The purpose of these is not just because we need to stitch the rails together, but it's actually that we are splitting the rails into individual bits to make the rails easier to move around manually, but also to manage longitudinal stresses. So expand, as these rails get hotter, they expand, and there's an expansion joint here, and this should be open to start with, and then it should this should be kind of open to start with, and as things get hotter, that gap closes up. So at a certain temperature, which by the way is 27 degrees Celsius, that joint will be closed. Actually, it might not be quite 27 degrees Celsius because the stress-free temperature doesn't necessarily tally to the joint closing temperature. But anyway, that is 2 fish plate or 4 fish plates, 2 visible on flat bottom track. However, and this is a little less clear in the picture, so apologies for that. Here we have a bullhead rail, which has this shape. If I do the cross section, it's got this kind of shape, which is kind of a. In theory, it was originally going to have the same shape, top and bottom. It didn't end up going that way. But here you can see, firstly, you can see a nice wide joint just about here. It's quite bright, so my yellow is no longer that clear, but there is actually a big gap here. If I draw a line to there and a line to there we go. You can see the gap. You can see the gap. The expansion gap, which is nice. You can see it down here as well, lovely. And you can see here once again. Here's a normal sort of fish plate, kind of it's kind of symmetrical in the vertical plane, 4-hole. There's something different with this one back here though, because if we draw this, you see there's this sort of funny skirt thing because bullhead rail is kind of in section. Kind of this bit here and this bit here are kind of okay. So there's this shape between them, but actually that. There's a dashed line between them. They're kind of level with each other. You can have a fish plate that expands over the edge, which is exactly what happens here. You can see this skirt, as we call it. This thing here is a skirt, and this means that this thing here is called a deep skirted fish plate. The point of this being that as we increase tonnages through the 1970s, and indeed before that actually, but certainly in the 1970s these got big rollouts, if you rolled the heavy axle loads over the top of this, you would create a lot of hammer effect between the 2 ends of the rail, because the bending strength of the rails isn't great. So, and also because of the way the fish plate sits in the bullhead rail, it's not hugely strong in kind of as it gets walloped over. So this extra skirt, that extra thick bit of metal, whether it was cast iron or another material, helped keep that joint a bit more rigid as wheels went over. So there you go. Hopefully that makes some level of sense to explain what fish plates are. I'm going to go big face and answer a few questions because there have actually been quite a few flinging through. Simon Zev Kendler says, not one of my yards. Correct. Gareth, where are you? You did ask a question and I've lost it. Oh no, blobby tables. Forgive me. Blobby tables. How do you get rid of a fish plate? Well, let's go back to my small face, and I'll tell you exactly how you get rid of a fish plate. In fact, if I'd kept the folder open that I was navigating in momentarily, I'd have been able to show you a picture. In fact, you know what? I'm going to do it. I'm going to find the pictures that I had a minute ago and actually show you exactly. Let's just open file location, yes, and find you a picture of what you can do to get rid of a fish plate. There will be one here momentarily. No, that's just two joints that are split over a bed, which is interesting. You can see an old, a wider skirted fish plate. These fish plates here, also £86 rail there, which is bad news, but it's a digression. There's got to be a picture of a welded up. There we go. That'll do nicely. There we go. That's what you can do. In here, it's not actually that clear, but basically this, in fact, that's a rubbish picture because that's not telling me what I want to see at all. It's worth. I promise you, this is worth it because the folder I'm in is my inspection pictures from a certain heritage railway. If I said Redmire, that means most of you'll know where that is. I'm just finding a picture of. There's a nice fish plate again, but you don't want to see that. What you want to see is you don't want to see a cracked fish plate either. Yikes. What you want to see is you also don't want to see a massive bruise on the railhead. No, you don't want to see that. What you want to see is a joint that has been converted from a fish plated joint into a welded joint. That's just a fish plated joint. Here is... that's interesting. Yeah. The annoying thing is you can't see the holes in that, but... there we go. That's the picture I want. There, good. That's the picture. So, as you can see here, to answer your question, here is a... just get that up and close that. Here's a picture of what used to be a bolted joint, and you can see the holes here where the joints were, and what they've done is they've just welded up the gap between the rails, and it was very common in BR days to do that on alternating, so to create 36 meter strings, as we call it, so to weld every alternating 18 meters, you just weld up both joints. So or you can sometimes weld up alternating ones to kind of minimize the stresses on the track, but that is one of the ways to get rid of them. The other better way to do it is to just pull up all the rails, and ideally in this case the sleepers, and probably refresh the ballast and just do a track renewal and lay it with new materials. Far better, because as you can see here, problems as a result of doing this with a really poor quality weld. Anyway, I digress. So let's go big face for any other questions before because it's already 20 past. We've not even opened up the PDF yet. Oh my goodness me. Let's see, at my name to see questions. And Michael C, forgive me if I've asked this before, but how do expansion joints work if you've got welded rail? Let's do a whole episode on that, but it's to do with the fact that we leave a gap in the rails, we pull them together, we weld them, but that gap that we leave, and then we pull them together so that there is a constant tensile stress in the rail that is 0 at 27 degrees rail temperature. So if you're anything less than 27 degrees, there's a slight tensile stress, which is good because it pulls the rail taut, and rails are, it's a long, thin thing, so you don't have the risk of buckling when it's in tension, whereas as soon as it's any compression, the risk of buckling is high. That ballast is a horror, says Simon. Gareth asks, if it did have the same shape top and bottom, could it be turned over once the top is worn? That was the logic with the rails, exactly. That was indeed the logic of it. It never worked because you always got galling on the bottom where it was connected. So where this bit here, where the fastening would kind of be clipped into the, where it sat in the chair, it would get galled, and where it rubbed, it would get galling, as in like rust and reducing the sort of section. So if you turned it over, it would look horrible and it would be all worn out and it would just be rubbish. So they never ended up doing that. It's a nerdy technical one, this one. Rick Townend, why is a tradition to not have the joint supported? Because you create the hammer effect that you get at the rail end would actually damage the sleeper in the fastening. You want some level of resilience at that. Some countries do put a sleeper in and support the joint, but my gut feeling is that it performs worse that way. You actually do want some level of give to create a dynamic system. You don't want a totally rigid system. Alice isn't necessarily right in this situation. Lewis Bergen's asking why 27 degrees. Let's do a whole episode on 27 degrees stress-free temperature. Let's do that as a whole episode. Remind me to do that. Put it in the polls. Right, anyway, let us get on with things. We must jump forwards to the 22nd of September 1983. Second trigger warning, content warning, because behind this date is a picture of a train that has fallen off the tracks here. You might be able to see lots of slightly weird repeated cloned images, because this is an Alamy picture that I have used Photoshop cloning to hide all the A's off, but you can see one at the end of the coach here if you look closely, because there's no pictures available of this image. I've kept it in low resolution, Alamy, don't be annoyed. And also I've sufficiently modified it that it doesn't count. You can see another A here that I've sort of half hidden. Anyway, point being, here is a train that's runned off down the hill. This is bad. We don't want our trains to not be on the tracks, and particularly we don't want them to be on their side off down the hill. Why did this happen? Well, we have to read the crash report to find out why this happened. And you know what? That's exactly what we're going to do. So, and I have my mouse so you can see the mouse, so we can have a proper look. Lots of questions about bullhead and fish plates versus... Continuous welded rail is infinitely better than jointed track, just on every level. It's much easier to maintain. It's much cheaper to maintain. So once it's installed, it's almost fit and forget, really. Whereas jointed track, multiple times a year, you need to go out, inspect them, lubricate them. Jointed track is much worse in hot weather because those joints close up. Whereas with welded track, once you've stressed it appropriately, you're kind of sorted. Interesting. Thanks, Jarrett AO. Yeah, that's a little question. But in terms of the 27-degree question, Lewis Bergen will come back to the 27-degree question in a future episode because it's an interesting one. Right, railway accident. Report on the derailments that occurred on the 22nd of September 1983 at Pitlochry in the Scottish region of British Railways and on the 30th of November 1984 at Pershore in the western region of British Railways, because we're going to bounce between both, actually. That was in 1983, but in 1984... And thanks very much to Mike on Twitter for sending over this newspaper cutting, because it's conveniently gave me an image to illustrate the other crash to give you an idea of what happened. 30th of November 1984, another derailment. But why are these two derailments coupled together? As you can see here, more than 100 passengers escaped when carriages of a businessman's special train left the tracks at Pershore and smashed into a bridge today. The railway doing praxis here. Here we go. So, this train coming off. You can see there's quite a lot of mess of the track. It's gone all over the place. It's quite a long train, a 10-coach train. 5 of the 10 coaches jumped the tracks at Norton Junction and Stolton. Golly. Yeah, that's not good. So why are these two reports, or two incidents, coupled together? Because this happened occasionally. They would couple reports together. £5.30 in the 1980s to publish this. Yeah, you can find this on the Railways archive, of course, by the way. Thanks to Gary Keener for maintaining an excellent archive. So let's do this. Let's have a look through. And the text is quite small in these, so apologies if it's so small you can't read. It shouldn't be. If you've got this on a big screen, it should be just about big enough that you can read it nice and clearly. Yes, something to do with fish plates, intimates Tom. Well, yes, perhaps, yeah. Contrapunctus mammalia. Is it true that continuously welded rails can have negative consequences with track circuits, at least where they need to be very exact? I don't think so, no. I see what you mean in terms of... Well, no, because within continuously welded rails, you just put an insulated rail joint, and it acts as a it's still, that still counts as being continuously welded rail. You just place your IRJ where you need it. That's no problem. Anyway, the same review in Apple Podcasts. Hello to that person, by the way. I'm not being annoyed at your review, actually. It's that's sort of quite reasonably delivered feedback. You said you enjoy it, but it's a bit chaotic. Yeah, partly because I have ADHD, and partly because the point is there's live chat in the corner most episodes, and I think people enjoy that interaction, and that makes this work. Because if it was just me yammering away, this would be rubbish, let's be honest. And my pre-record episodes where I'm not with a guest or out and about are a bit rubbish. So... as ever, these always start. If you're familiar with this era, the Railway Inspectorate era of crash reports, sort of right the way through to the privatisation era. Sir, I have the honour to report for the information of the Secretary of State in accordance with the direction stated. The result of my blah blah blah. It's the sort of standard intro for these things, and kind of the opening bit is basically the explanation of what happened, but we'll not read the quick intro. We'll kind of have a read. We'll set the scene and have a little read of the body of the report. So we'll start with Pitlochry. So the Pitlochry derailment. Pitlochry lies on the line from Perth to Inverness and is 28.25 miles from north of Perth. For the majority of the route, the line was constructed as a single-track railway with passing loops at the intermediate stations, including Pitlochry. The derailment took place on the single line between Pitlochry and Ballinewig, some 1,200 metres to the south of Pitlochry. By the way, this line should have been dualled a long time ago, but that's another story. South from Pitlochry, the line runs on a falling gradient in the up direction towards Perth. From Pitlochry Station, the line runs approximately from north to south to the east of the River Tummel, and with the roadway, the old route of the A9 trunk road through Pitlochry to the railway's east. Okay, fine, yeah. That's the description of what's going on. Lovely. Fine. The single line, it's worked according to the Scottish Region's tokenless block regulations. The derailment took place beyond the signals at Pitlochry Station. The method of signalling had no direct bearing on the accident. Worth saying, pretty much exactly the arrangement that the railway looks like now. Okay, they've extended that loop a bit further, actually, in Pitlochry pretty recently, but by and large, this is, the area, indeed, because the A9 construction, Thatcher's A9 upgrade, pretty much it had been finished by this point as well. So it's interesting that this is pretty much the railway and road layout that people will be familiar with now. The passenger train, what was it? 1 Tango 04 consisted of 9 bogie vehicles bogies hauled by a diesel electric locomotive. What do we know what it was? We've got a load of non-passenger vans full of crap. We've got 2 passenger coaches, tourist standard opens. We've got a couple of sleeping cars, and then another couple of tourist standard open passenger coaches. I don't know the codes well enough to know if those sleeping cars and passenger coaches are Mark 1 or Mark 2. But from the image, it looked like both, to be honest. If I flip back to the image, let's flip back to the image. It looks, so that's a Mark 1, which looks like a sleeping car. But those are Mark 2 coaches, or that was a Mark 2 because it's got the rounded. Yeah, anyway, a mixture of coaches, fine. I don't know what the locomotive exactly was. Probably. Oh no, I do know what it was. It was number 47470. It's a Class 47, the best diesel loco Britain ever created. Anyway, locomotive connected to the train by means of a screw coupling of the locomotive. The vehicles of the train were coupled together by Buckeye couplings. Vacuum brakes coupled and operative throughout the train. Fine, lovely. Yes, indeed. So. Yes, thanks, Graham. So track work, fine. There's a load of 113A flat bottom rails rolled in 73. Oh god, pre-76 rails, supported on MRC1 base plates. Horrifying. Dated 1963 with Mills clip fastenings on softwood sleepers. Golly. From 20. So that's for a bit. What was that? That's just 30 yards. That's classic railways are just an absolute hodgepodge of all sorts. Yeah, okay. So then the next bit is £95 bullhead rail, rolled in 46, 60-foot lengths, deep skirted fish plates, rails supported by CS1 through bolted chairs dated 56 or 57 on E-type concrete sleepers. That's not what I wanted to hear. We've moaned about concrete sleepers in the bullhead concrete sleepers in the concrete sleeper episode. So I'm already unhappy seeing E-type concrete sleepers with bullhead on top. That's bad. Except immediately adjacent to the joints where there are AS1 chairs on timber sleepers, because that was basically retrospectively applied because the concrete sleepers performed so poorly next to joints, they just crumbled to bits. And then we're back onto and there's still bullhead, except that there were coach screws in timber inserts adjacent to the joint where the derailment occurred. The rails are supported on concrete sleepers. So already I'm like, oh well, there we go, there's some problems. So, fine. Some stuff about curvature and so on and so forth. Lovely. The course of derailment and the accident damage. Travelling at 40 to 45 miles an hour, the locomotive and the first 3 vehicles successfully negotiated the joint in the left-hand rail, the fish plates of which were both broken. Okay, boop. What? Broken fish plates. There's your root cause. There's some broken fish plates. Fine. The remainder of the train, commencing with the 4th vehicle, then became derailed. The 4th vehicle, uncoupled from the front of the train and still coupled to the 5th vehicle, turned over down the embankment to the right-hand side of the line. The 6th vehicle, uncoupled from both the 5th and 7th vehicles and remained upright on the line of track. The rear 3 vehicles, still coupled together, demolished the parapet of Underbridge 58, turned over down the embankment on the left-hand side of the line. The broken joint was on underbridge number 59. Oh, golly, it was also on an underbridge. So we've got concrete sleepers and an underbridge, making it quite a resilient system on which bullhead is very poorly suited. And we've got this rigid joint. So there are lots of confounding factors here. They're not good. After the derailment, it was possible to re-rail the 6th vehicle, one of the sleeping cars, but the other derailed vehicles, which were down the side of the embankment, were all so extensively damaged as to be uneconomical to repair, and they were removed by road or broken up where they lay. sack those off. Yeah, fair, fine. There was damage to telephone cable. Poor S&T folks' cables were wrecked up as well. Fine. So there's a disposition of vehicles of the train after the derailment is shown in Figure 3. Fine. Driver Ford was at the controls of locomotive 47470, hauling the 2350 Inverness to Glasgow passenger train at the time of the derailment. Isn't it just an Edinburgh to, Inverness to Glasgow passenger train with just a bunch of other stuff marshalled into it? Like a couple of sleeper coaches, some post, some newspapers in vans, and possibly a couple of motor rail cars, perhaps in the all the sorts of things that you could that we had on our railways not that long ago. It's weird to think, isn't it? Anyway, earlier he'd worked the same locomotive, the 1853 passenger train from Perth to Inverness. He told me that the locomotive was in good mechanical order and that the journey north had been without incident. The return journey from Inverness was also without incident until after the scheduled stop at Pitlochry. He said that on the departure from Pitlochry, the train had travelled about quarter mile and reached a speed of between 40 and 45 miles an hour when there was a bump. At first, he thought the locomotive had struck something on the line. The locomotive then gave a bit of a shudder, and there was a tugging and pulling from the train. He shut off power, and as he was about to make a brake application, saw the vacuum gauge fall to 0. Yeah, it's always interesting to think what happens when it happens behind you. So it's kind of interesting to read the account of the driver of what happens when that happens behind you. It's like, it's interesting the driver can perceive that feeling of it. It's tugging at something. When the locomotive had stopped, both he and the relief driver dismounted and walked towards the rear of the train. As they did so, they met one of the guards in the train, and together they discovered the first sleeping car was on its side, and the next one was down the embankment. And there they are. They confirmed the driver's evidence. So there we are. He was traveling. So there was a guard traveling in the leading brake van, which was marshalled immediately behind the locomotive. He told me that he heard a thump as if we were going over a slack joint, and there was a rugging from the rear of the train. He steadied himself by holding onto the handbrake wheel, and saw from the brake gauge that the vacuum had been destroyed. So there we go. Guard Marshal had joined the train at Blair Athol, gave the signal for the train to restart, and boarded the Glasgow sleeping car, where he remained, talking to the sleeping car attendant in the pantry of the car. Just having a nice chat on the train. Nice staff, saying hello, lovely. He realised that the coach was derailed and it was bouncing around as it ran along on the sleepers. He told me that the coach suddenly turned over, and at first he did not know where he was. He was eventually able to get out the coach and help some of the passengers out. Guy, yeah, it's a pretty frightening situation. And so there's lots of people explaining things. So let's go now to Trackman J. Haggart. Told me that he'd been employed for just over 2.5 years as a plate layer, and that his duties included patrolling the line from Mullinern to Blair Athol, a distance of some 10 miles, when the regular patrolman was not available. During these patrols, he made a visual inspection of the track, carried out minor repairs such as replacing keys. If he found a defect, this is the standard thing. You still had lengthmen and people who are kind of in charge of their bit of railway. If he found a defect that he could not reasonably tackle there, he would report it to his superior, either the ganger or the inspector. All these sorts of roles that essentially don't really exist anymore. Imagine that, yes. Lots of people discussing things. All sorts of good chat going on. Good. So this chap, what's his name, Haggart, said that he patrolled the section line on Monday when he would walk from the south to the north, and on Wednesday when he would walk in the opposite direction. To walk the whole 10 miles of the line would take a full working day. As usually, walked from north to south on the day before the accident, and he looked at both of the rails, but paid most attention to the right-hand one, as was his normal practice. It was a showery day, because then you kind of look at one, focus on one, because if you look at both simultaneously, you potentially miss things. So you look at one, work your way along, and then you look at the same rail, but go in the other direction, and you kind of catch things that way. It's quite a lot. I've done the same when I track walk. I've done this role on Heritage Railway. It's a pleasing role. That's what those photos are from, by the way. So it was a showery day, and although it was not raining, he walked through Pitlochry about 2. It was shortly after a shower of rain. It was dull and ground, so the track was wet. He noticed no defects in the track on the length of the line to South Pitlochry, and was sure he would have seen a completely broken fish plate. Okay, fine. So there's basically lots of input here. So we see lots of. We're going to read all of these, but you can see all the evidence collected, and they basically record the evidence, so on and so forth. So then we get some, so we've got evidence from lots of different people, the Divisional Civil Engineer, examination going on, and all the feedback, and then the Senior Carriage and Wagon Inspector for the CMEE for Scottish Region, the Chief Mechanical and Electrical Engineer of the Scottish Region, so the person in charge of trains for the most part, and just some evidence from the damage that had happened, the vehicles shedding their bogies. He was able to identify the site of the initial derailment as being on the underbridge. and you could spot the fish plates of the broken fish plates. You can see the marks on the inside of the head of the rail where the wheels had raised up. So all the telltales that you can get, that you can pick up, that you can get. You can go and have a course in crash investigation, rail crash investigation, if you want to understand how all these little tells and things that you pick up to understand. In fact, we'll have a rail hour about it at some point. It's quite interesting, quite an interesting subject. Our BRB's BRRD, the British Rail Research Department, here giving evidence. So again, they'll have kind of analysed what had happened and understand kind of what they'd expect to see happening. So just saying, yes, that's pretty much consistent with what we'd have expected to see. So they then go out, they get the bits, they put them back together again. So you get the joint and reassemble it. So here you can see these horrible E-type concrete sleepers, absolute hell sleepers, and you can see the joint, and it's a deep skirted fish plate, a bit like the one that I showed earlier in the picture. You can see, firstly, you can see the fact that this is a really walloped. You can see the end. I don't know how clearly you can see that actually, but you can, if I zoom in, you can see the extent to which the ends of these rails have been hammered by wheels passing over it. It's an unhealthy looking joint. If you're seeing that, then it's not necessarily good condition, because every time a train goes over that, you get a hammer, which is obviously puts a load of stress into, massive impact stress into that joint. But there you go. You can see it's broken, folks. It's not happy. So the bottom of each fish plate fracture face had areas of dark corrosion, typical of fatigue cracks. The reason the fatigue, you can tell a fatigue crack because it's been an open crack, so you get rust in it. So the area that's been broken immediately before the crash will be, firstly, it'll be spiky. It'll look like if you've stabbed, it'll look like chipping away at Parmesan. The bit where you put the knife through is smooth. The bit where it just naturally breaks away from the Parmesan is all spiky. Well, kind of rough. That's what metal looks like when it fails this way. So, unless there's a pre-existing crack, because metal is a crystal structure. It has a crystal structure, so you get that kind of erratic break, other than where you've got fatigue. So in the area where the crack exists, you can tell there's a crack because it'll be rusty. There'll be a dark rust, a kind of blemish within the broken steel. I think I've shown pictures of that when I looked at 100 ways that railway rails fail. So all four pieces of fish plate were steam cleaned, and the fracture faces were derusted in an inhibited acid solution, basically so that they could inspect them closely and understand how these cracks perhaps had formed and understand what had happened. So there you go, yeah. And this describes it quite very nicely. So, bottom of each fish plate, we described the dark patch grown over a long period of time. Upper part of the fracture faces was, in each case, a brittle fracture with fresh, light brown corrosion and a moderate amount of damage due to contact between the ends of the broken ends of the fish plates. So, a bit of damage from them bashing into each other. This contact indicated that the chair keys were in position when the joint broke and that the fish plates were securely corrected to the rail ends. Yeah, so just in case it was... People thought that maybe the fish plate had been broken as part of, in the course of the derailment rather than an indicator of it. In summarising his findings, Dr. Allery said that the derailment was caused by the complete failure of the pair of fish plates due to brittle fractures initiated by fatigue cracks. Under normal loading conditions, the fatigue cracks would have been growing for a considerable period of time, although he did not consider the cracks would have been visible to a patrolman making his normal inspection. The fatigue crack in the 4-foot fish plate predated the final brittle fracture in the cess-side fish plate, but the final brittle failure of both fish plates probably occurred about the same time. Fine. By the way, I'm using gendered terms here because that's the terms that are being used within the report. For all the women who are watching / listening, these roles are named, in this case, old-fashionedly and stupidly. They don't really exist like this anymore. We don't name roles like this. These roles are open to you. Come join us. Screw these guys. So, right, that's Pitlochry. There's a kind of a summary of the Pitlochry derailment. Let's talk about the Pershore derailment now. So, are you following the story? So the cracks weren't new. No, absolutely. The cracks didn't happen immediately. Those cracks had existed already. Ooh, plot thickens. What are we going to learn from that, though? So let us think about what's going on again. And when I talk about the best locomotives in the country, then it's because the 47s got everywhere and ran everything. Sight and signalling. So let's talk about Pershore. It's a very different part of the country now. Pershore lies on the line from Worcester to Oxford, the general direction of which is from the northwest to the southeast. A line currently famous because Newnham... it's the other side of that, actually. But, ignore me. Newnham's the other side. Anyway, I digress. The general direction of which is from northwest to southeast. From Norton Junction, where the line to Gloucester diverges to connect with the Birmingham to Gloucester line, the Oxford line continues as a single-track railway to Morton in Marsh. There's a passing loop at Evesham Station. Okay, fine. Lovely. The passenger train was the 0705 Hereford to London via Worcester and Oxford train. Consisted of 10 bogie vehicles hauled by a diesel-electric locomotive. The leading vehicle was a non-passenger carrying van, then followed in order a passenger brake composite coach, 7 passenger coaches, and finally another passenger brake composite coach. The total weight of the train was 334 tonnes. Yeah. The locomotive number 47500 Great Western weighed 117 tonnes. It's Class 47. It had a Coco wheel arrangement, yes, we know, and a maximum permissible speed of 95 miles an hour, same as the previous one. Lovely. You can hear my poor daughter, who's not very happy. Right. The locomotive was connected to the train by means of the screw coupling of the locomotive. Yeah, so it's the same deal. Buckeye coupling's fine. Track work. The track work on the line between 114 miles 52 chains and 115 miles 60 chains consisted of 95 pounds per yard bullehead, 120 foot lengths. So again, 36 metre strings. They've welded alternate rails here. So a bit like what I showed you. So that question was a very good one. The report is labelled it Worcester rather than Worcester. Is it? Oh yeah. Messed up. Do they do the same again when they describe it later? Yeah, they do. How? Worcester. How bizarre. Very strange. Anyway, supported in cast chairs with spring steel keys on concrete sleepers in stone ballast. Once again, concrete sleepers. The rails were connected by 4-bolt deep-skirted fish plates. The rails dated from about 1960, but the sleepers were probably about 12 years older. The deep-skirted fish plates were installed in the early 1970s and were probably not new ones, but ones which had previously been used elsewhere. This section line was proposed for relaying in 1983, but awarded a relatively low priority. Cheap and cheerful. Following a concentrated maintenance program, including the mechanical straightening of dipped rail ends, the line was re-inspected in June 1984, because this is a year ahead now, we're in 1984, the previous one was 1983, wasn't it? And the condition of the line was sufficiently improved for it to be withdrawn from the relaying program. Fine. The course of derailment and accident damage. At the time of its derailment, about 8:10, the train was still accelerating after the reduction in speed over Norton Junction and had reached approximately, so this is faster now, 75 miles an hour, so it's substantially higher speed. The point of the derailment was readily identified as a joint in the right-hand rail in the direction of the travel of the train, where both of the deep-skirted fish plates were broken in two, and a 5.5 metre length of the rail beyond the joint had been overturned outwards. Oh, yikesies. On hearing a loud bang as the train ran over the joint, the driver of the train realised that something was wrong and made a full emergency brake application, which brought the train to a stand a kilometre beyond the rail joint. Only the first 6 vehicles were still coupled to the locomotive. 1 pair of wheels of the 5th coach and 2 pairs of wheels of the 6th coach were derailed. The rear 4 coaches were all completely derailed, and although still coupled together, were separated by 608 metres from the front part of the train. So, it's good that they're all still coupled together. The 7th coach was derailed to the left of the line and into the cutting slope. The 8th coach was skewed across the damaged track, and the 9th and 10th to the right. The 9th coach was leaning against the brick pier of a 3-span overbridge, golly, and the 10th against the cutting side. So it's a good job that the energy of this train had been sufficiently dissipated by the time those collisions happened, frankly. Tim Ballon's asking, they have welded 2 rails like that on a few Heritage Railways. Yeah, lots have that. Mostly because, not the Heritage Railway's done it, but because BR had done it when before the Heritage Railway got hold of it. So there we are. There we go. What else have we got to learn? So there's lots of evidence. Once again, we've got Mr. Weaver from the BRRD. Lovely, marvellous British Rail Research Department. That's what it became. Maintenance engineers. The damage to both rail ends at the joint indicated that trains had run in both directions over the joint after it had failed. Oof. Golly, the last train to run over the line towards Worcester was a diesel multi-unit at about 23:10 on Thursday the 29th of November. It is considered, however, that this train would not have sufficiently heavy axle loads to account for the batter to the end of the rail. A locomotive hauled passenger train passed shortly after 8 p.m. on the 29th of November. It's likely that the fish plates were already broken at that time. So there's already an indication of what was happening. And indeed, the picture that you saw with the batter in the previous image, that batter might well have been occurred after those joints had broken. So they could have been broken for a while, which is interesting. Once again, they did the same thing, same testing, and had a good look. Deep skirted fish plates, blah, 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 blah. So, further investigations. Let's dig into what other investigations occurred after these two, and why they've been coupled together. So, the deep skirted fish plates for bullet rail were introduced in the early 1970s to replace... Right, so, those deep skirted fish plates, they were introduced in the 1970s because we were seeing quite substantially increased annual tonnages and indeed higher kind of axle loads, and it was the 1970s when we increased when freight axle loads were increased basically to 25 tons. We started enabling 25-ton axle loads, which needed stronger fish plates. So prior to the failure of both fish plates at one rail joint, which caused a Pitlochry derailment, the simultaneous breaking of both fish plates at a joint was virtually unknown. It's worth noting that fish plate failures accounted for some serious derailments. In 1981 was the last one, which was up in Elgin, which was the last of the fatal derailments as a result of broken fish plates and broken rail ends from star cracking. Actually, it's not the fish plate joint itself, but actually the rail end cracking within the joint that's a problem. So joints are already acknowledged as a serious problem at this point. There was, however, considerable evidence that the cracking of deep-skirted fish plates was not unknown. The extent to which this occurred was not fully known because there was no comprehensive record of the numbers being found and changed by patrolmen. Yeah, keep good data. There's a little thing for us to learn there. It's on the Cotswold line, is what Simon's pointing out. Thank you. This is just the Worcester side of the recently opened Worcestershire Parkway station. Thanks, Simon. In order to try to establish if the failure of the fish plates at Pitlochry was an isolated incident or if it was symptomatic of a wider problem, basically they inspected a load of deep-skirted fish plates removed from a length of line during the programme renewal of the track. What's interesting is no one's specifically talking about the concrete sleepers as being the reason, or the exacerbating reasoning here. I'm interested to know whether they picked that up by the end of the report, actually. They extended the survey during 1984 to all regions of British Railways from just the Scottish region, so they removed a sample number of fish plates from the track, sent them to BRRD, and results of the survey, which was drawing to a close as the second derailment occurred, were not consistent. The three regions that carried out a mainly visual survey did not consider that deep-skirted fish plates gave cause for concern. The Scottish and Eastern regions gave different sample sizes, but 2% of the fish plates from both regions were found to have fatigue cracks at the bottom of the skirt. So this is an issue that is certainly present. During 1984, BRRD, as well as examining fish plates on behalf of the two regions, undertook testing in the lab to measure the stress at various places in a deep-skirted fish plate subjected to load. So there we are. We've got action taken since Pershore derailment, fine. So you can see we've got our different categories of track based on... This is the original track categories before they were updated in Network Rail Times. These are the original track categories here. So what used to be 4A is now 1 or 1A, but these are the old categories, and they used to do it separate by speed and by gross tonnage. That used to be the way they categorise it. We've kind of updated that now and simplified that system because that gives you quite a lot of different options, which isn't hugely helpful. And we know also that speed is actually less important than tonnage for dynamic behaviour of track materials. Anyway, a line with a maximum permissible speed of 125 miles an hour carrying 30 million tonnes annually would be classified as A4. Yeah, lovely. Fine. It's interesting. We've got the stats of how many single track miles of bullet rail there were at the time. 3,886 single track miles. So what is that? That's about 5,500 single track kilometres of bullet. Crikey. 18% of the total single track mileage of the British railway system. Yeah, it's a good old chunk. That has reduced a bit since then, I'm pleased to say. Anyway, right, so we don't need that detail. But here's a nice cross-section of the deep-skirted versus the regular bullet fish plates. There we are. The difference between the two. There's a nice section there. There's a nice cross-section of the bullet rail as well, so you can see it. Lovely. This doesn't. We don't. They're always. We never do them like this, or you should never do them. You should always do them the same either side, because otherwise you eccentrically load the joint. But this is just illustrative. And there's a nice breakdown of the different line categories. You can see how many bloody line categories this gives you: B's, C's, D's. Anyway. So following derailment, all deep-skirted fish plates identified as being 10 years or older, or fish plates the age of which could not be determined, on higher categories of track on concrete sleepers. There we go. So they have realised that that's an issue. Should be replaced by new deep-skirted fish plates. Not all the track with bullet rails has deep-skirted fish plates. Fine. There we go. So fine. But they reckon the majority of fish plates in category B and C lines are deep-skirted. The majority of all deep-skirted fish plates were installed in the early 1970s, and the instruction means that the majority of the 25,000 fish plates on 72 miles of track will need to be changed. It's probable that all will in fact be changed because it's less expensive to change the fish plates than to remove the existing ones and then clean them to establish the age of the few which are not 10 years old. So, okay, basically, they're going to replace all those because it's just easier to do that in a working of scale. Fine, so they're getting on with that. There's the Director of Civil Engineers asked the regional civil engineers to undertake the work as soon as practical. Orders have been placed with manufacturers to supply the new fish plates in sufficient quantities to enable the work to be carried out at the same time as the regular annual adjustment to and oiling of fish plates in the spring and early summer 1985. Fine. So there we go. Lovely. Now, what are the conclusions here? What can we conclude from this? Well, because there's a bit to talk about here. So the derailments were both caused by the fracture of those deep-skirted fish plates at a bullhead rail joint in track that was otherwise properly maintained. The fracture of the fish plates originated from fatigue cracks in the skirts of the fish plates between the rail ends. Fine, okay, yeah, we understand that. The final failure of each fish plate then took place by rapid brittle failure. The interval between the failure of each fish plate within a pair was probably small. So once one went, the other one went pretty quickly because it was being overstressed. I will scoop up all the questions, by the way. Actually, there's only a couple. Gareth, is this a brilliant example why the railway needs to be a unified organisation? Yes. Marvin the Android, are the fish plates rolled steel, wrought, or cast iron? They can be cast iron, they can be rolled steel. These are often cast iron, but they often end up being rolled steel. I'm about to put a drawing up which will tell you what the material is momentarily. So it's interesting that they don't really make a big deal of the fact that the key problem here is the concrete sleepers. So it's interesting they haven't really picked that up here. The evidence suggests that fish plates with fractures which were visible were seen and replaced by patrolmen, even though senior supervising engineers may not fully appreciate the actual number involved. I'm confident that in the case of each of the derailments, had one or both of the fish plates been fractured beyond the fatigue crack, it would have been found by the patrolmen concerned, and therefore no blame attaches to them. Oh, there we are. It's always nice. I was quite nice when they make sure that the worker isn't being blamed for this, which is good. So it's interesting that isn't specifically being picked out. So what are the remarks and recommendations here? There's some pictures which we'll have a look at in a second. Well, first of all, the BRB, the British Railways Board, are of course ultimately responsible for all aspects of safe operation of BR, a responsibility that they discharge most seriously and properly. Oh, there we are, that's nice, isn't it? The action to be taken following the discovery that deep-skirted bullhead fish plates are subjected to fatigue failure after they've been in service for 10 years or more is a matter for the board and their Director of Civil Engineering to decide. Fine. Here's pictures showing the kind of the fatigue cracks, so the kind of the dark areas of where those breaks occurred. So you can see that not much on the Pershore failure, which is quite impressive, whereas at Pitlochry it's substantially greater, but the tonnages at the annual tonnage is much lower on well, actually maybe it isn't, actually, because it's the Highland Main Line. It could be the other way around. I'm not sure. Anyway, I do, however, fully endorse the action to change the fish plates. Fine. No, here we go. I'll read that again more clearly. I do, however, fully endorse the action to change these fish plates for new ones on passenger lines where the track is laid on concrete sleepers. It is known that concrete sleepers, although they have many other advantages, are less resilient than timber sleepers. Resilience, actually, here specifically refers to elasticity, as in bounciness. Are less resilient than timber sleepers, and when subjected to heavy impact loading can rapidly disintegrate with the resulting collapse of the track, as occurred at Pershore. The logic of the decision to change the fish plates at joints with concrete sleepers is clear. The risk of fatigue cracking, followed by the rapid complete failure of the fish plate, together with the subsequent rapid destruction of the concrete sleepers adjacent to the rail joint, is obviously unacceptable. So we didn't read that earlier, but actually it's worth saying that certainly the Pershore failure, it didn't happen at the Pitlochry failure because we saw the sleepers, but at Pershore the sleepers were crushed and destroyed by the failure. So that just means the joint is wiped out, which is bad news, obviously, in terms of supporting the track. I believe, however, that it will be advisable to monitor closely the old fish plates that remain on track with the timber sleepers, and if situations are identified where the risk or the potential result warrants it, those fish plates should also be renewed. As can be seen from the photograph of the track from Pitlochry, unlike Pershore, the failure of the fish plates was followed by breaking of the chairs rather than disintegration of the concrete sleepers. Fine. So there we go. So they're saying once this program of replacing is done, I recommend that not only should all the fish plates removed be disposed of, but that stocks of existing deep-skirted fish plates, unless it is certain that they are new and unused, should be disposed of in order to remove the risk of old fish plates being used again as replacements. Okay, fine. So there's no laid down instruction that patrolmen should associate the thing about record keeping and data. Fine. The introduction of the deep-skirted fish plate took place over a very over a relatively short period of time in the early 1970s, when the widespread introduction of vehicles with a 25-ton axle load necessitated the use of a stronger fish plate. While the relaying of lengths of line with either new or serviceable continuous welded rail will eventually remove jointed bullhead rail track, the present foreseeable rate of its replacement means that on many of the secondary routes, jointed bullhead track will remain for some years. Correct. I recommend, therefore, that the work to analyse the stress within deep-skirted fish plates should continue with the aim of producing a design of fish plate less likely to be affected by fatigue. And a last point that's always worth paying attention to, all the last points. It is a rolling programme, Gareth, you're right, of renewal. In both derailments, the Buckeye couplings between coaches separated during the course of the derailment. In most eventualities, the damage to vehicles, and with it the risk of more serious injury, is increased if the train separates as spectacularly as it did at Pitlochry, and to a lesser extent at Pershore. And yet we still have trains running with Buckeye couplings today. In the Pitlochry derailment, it was considered to be because the excessive vertical movement of the derailed vehicles caused one coupling to rise relative to the other and allowed them to disconnect. The reasons for the single uncoupling at Pershore was not as firmly established. It may have been due to the snagging of a release chain, or again, it may have been due to vertical movement. There we go, fine. There's a discussion of the derailment at Bushy, where Lieutenant Colonel A.G. Townsend Rose recommended that means should be found to prevent the vertical disengagement of these couplings. That was a previous derailment. Although some modifications have been made to the Buckeye couplings, it is evident from these accidents that more work is necessary before the problem is solved. I have the honour to be, Sir, your obedient servant, A. Cooksey, Inspecting Officer of Railways. That's to the Permanent Under Secretary of State, the Department of Transport. There you go, there's the report. Now, what happened to deep-skirted fish plates after that? What happened? Oh, firstly, let's have a look at some diagrams here. So, there's the point of derailment. And here's where you can see the train has kind of just fallen off the side of the embankment. Sleeper train that's upright. And then these bits that are on their, the bogies here. Trains lying on their roof, lying on the side. And here's the loco having pulled those other coaches further on. So, that's not good. What about Pershore, where we have to zoom in a bit because of the fact that the train dragged the thing for so long. Point of derailment here. Note the nice millimeters here in the early 80s, by the way. Lovely job from the inspector. Very nice. Also the wrecked track as well. So there we go. Derailed coaches, and then there's a bridge. And actually, wait a minute. There's the... Oh, yeah, because one of the coaches was resting against the... Yeah, okay. And then the split, and then the rest of the train up this end. So it's a good job that it happened under the back of the train, not the front of the train. But these wheels, it happened here, but luckily these bits kept kind of attached and continued on the track. But this still wrecked the track by the derailed bogies. So there you go. And I think that's it. That's our report. So, what can we learn from all this chaos? It's absolutely remarkable that no one was hurt, particularly the second one. So there's a good rule of thumb that 100 kilometers an hour is a good splitting point. Above 100 kilometers an hour, derailments can cause serious problems. Under 100 kilometers an hour, under 60 miles an hour, generally things are less risky, less likelihood of serious, because the energy is that much less. What can we learn from this? Well, first of all, let's have a look at deep-skirted fish plates. This is the REPW, as we call it, the standard drawing for deep-skirted fish plates as they are. Here it is. As we install them today, we still do have them. They are we have bullhead rail. We still have all Great Western rail around, and so we have deep-skirted fish plates to deal with them, and they're much and such the same design. You can see here that they've got this sort of pretty much exactly the same cross section. If we in fact go back to the shape of the joint here, you can see that it is pretty much unchanged. There's not really any change to them at all. So the section is pretty much the same. It'd be nice if we had a full detail of the previous one, but we don't. What is interesting, firstly, there's some stuff about the steel. So it's steels in this case. They're not cast iron anymore. Much more durable. We don't use pear-shaped holes anymore, so we get rid of those. And what's interesting is if I go down here and look at the drawing revision, this drawing is the original drawing from the 70s when they actually created the bloody thing. So, actually, when they updated it in the 70s, they presumably when they rolled out these deep-skirted fish plates at scale, they reevaluated the design. So the technical expert went, okay, right, well, we're going to slightly improve the fishing angles. So that's some of the the various angles in the joint to sort of some of the angles over here, just to make sure that it survives a bit longer, is a bit more durable. Then, interestingly, at the end of 1983, so the 6th of December 1983, so in amongst when our report was being written, pear-shaped holes replaced by drilled holes. There we are. 1997, it was redrawn in CAD, and 2009, we updated the catalogue numbers, weights added, rail section names were brought into line with this current standards, and there we go, marvellous. So there's the revisions we've got. This is a drawing on by Network Rail. Happy days. Andy Jones signed it off, who's the head of track engineering in 2009. It definitely is not anymore. A chap called Gareth Evans is generally responsible for this stuff nowadays. Anyway, there we go. Rolled steel is the answer. That's what it was. Rolled steel nowadays, but in the past it was other materials also. So there's a nice drawing. Here's how the thing looks, and there you go. And you can see that we're still using these. Also, if you want the just in case you need to know where the self-locking nuts, fish bolts, headlock washers are, that's RIPW 263 and RIPW 170. Just in case for the nerds out there who need to know this stuff. Anyway, right, there we go. So it's still there. We still use them. The issue, as we kind of as you realise, is the durability of the joint, particularly on concrete sleepers. So that if particularly in the case where you saw. At Pitlochry, where it happened on a bridge, where you've got that additional kind of non-resilience within the system. Nowadays, so it's a very good point Alex Cusden just said, is that we cold expand drilled holes too. So Elgin, the failure at Elgin in 1981 was the last in a long line of joint failures for fish-plated joints, and essentially you got star cracking in the hole within the drilled hole in the rail. And at long last, and in a roundabout way. In fact, we did this, didn't we? We did 4 derailments that changed P-way a couple of years ago. It was after the slab track episode, a long time ago. That cold bolt expansion was introduced, which was in a roundabout way had come from the research done after the Comet disasters. So, interestingly enough, full circle on that one. Yes, we do indeed cold expand. We have a funny mandrel goes in, we cold bolt expand, and that means that you get a constant compressive force around the hole in the rail. But also, I think we cold expand the holes in the fish plates as well. So never ever drill a hole on site. Do not do that, and absolutely without cold expansion. And do not torch cut holes ever. Do not do that. Exactly as Alex Cusden is saying. Thanks, Alex. Spot on. Right, there we go. So we've kind of what else have we learned, folks? Well. What's interesting is that we've learned a little bit about what happens when you do a massive, almost panicked change to the system, like we had in the 1970s. We're like, oh, we need 25-ton axles. Right, okay, well, deep scraper fish plates. It shows why you do have to spend a bit of money on thinking about what the implications are of some of these big changes. I think that's one. Anything else anyone can think of? For me, I like going through these because they're a bit forgotten, these incidents. Although they're pretty serious. Thankfully, no one seriously injured, but the derailments are pretty serious. I mean, not least in the damage caused in terms of wrecking the vehicles and closing the railway. But derailments, particularly the Pershore derailment, what was it? It's a decent speed, wasn't it, where it happened? It was pretty 60, 70 miles an hour, 75 miles an hour, wasn't it? So it's pretty fast. Not good. So there's that. There's it's always nice to look at the sort of secondary impacts in terms of the research that had to be done and the fact they then had this rolling program of change to kind of check that these joints had not been fatigue cracking. Ultimately, this is what happens when you have knackered. The reality is that bullhead rail with fish plates like this is not appropriate under traffic really anymore, and it wasn't actually in the 80s either. So renewing being slightly ahead of renewals is not a bad thing, which funnily enough is not what we're going to be doing in the next control period. Jarrett AO is saying, so fish plate puts right, so first things first, this is on bullhead because it's slightly different on jointed track. You can have concrete sleepers and bullhead on flat bottom rails with jointed track. Concrete sleepers next to the joints is okay because the rails are that much tougher. The overall system is also the problem with concrete. They didn't talk about it in the crash report, but the problem with concrete sleepers on bullhead, as we talked about in the sleeper episode, I think, is that there's no resilience in the system. The cast iron plate is just on top of the sleeper. I think they went to some effort to put wood in there for a while, but it's just that, so it's really rigid. Whereas modern concrete sleepers, there's a resilient pad between the rail and the sleeper. So you get a bit more resilience in the system. So and the fastening's got a bit of resilience. So actually, for flat bottom rail, concrete next to joints is fine. But, as Jarrett is saying, for bullhead rail, you need wooden ties. Basically, get rid of concrete sleepers in bullhead track. You need wooden sleepers in bullhead track for it to be appropriate and safe. Note how much bullhead rail is still in use in London Underground, although a lot of it is being renewed now. Pretty much. Are these older reports as good and informative as current ones? No, they're not. They're often very good, and some can be very, very detailed, but they aren't as exhaustive a study as the RAIB's current reports are. Does the monitoring chain pick up these types of faults better? Yes, so we don't ultrasound scan joints like that, but a crack like that, and even potentially just a slight crack at the bottom would likely be picked up by the inspection trains. Yeah. Bullhead is fundamentally the problem here, and no, most of the world does not use bullhead rails. So it is a kind of a uniquely British, well, not a uniquely British, but a largely British issue. So concrete under bullhead is the bad news bit, really. That's the main thing. Continuous welded rail on wooden ties can be fine, but not great, to be honest, because the wooden ties... I'll reword that. CWR with wooden sleepers / ties isn't particularly good because wooden sleepers are light, which means they're not very good at... Well, they have very low... They're also not great for embedding into the ballast. They have a pretty low lateral resistance, by which I mean they're not good at resisting buckling. So ideally, if you have a continuous welded rail, you want nice, heavy concrete sleepers. Alex Cousin is saying we do ultrasonic them. Oh, yeah. Do we? Is there a case for using wooden sleepers for sustainability? No. Because they don't last as long, so you have to replace them more, and there's more carbon coming from going and replacing them than you get from chopping the trees down. So hence why we're using composite sleepers. Alex Cusden, we do ultrasonic it. Well, there we go. We do ultrasonic fish plates, so that it makes things easier. Is there like a handheld doodad that you walk out and touch them with? Alex might provide us that information. While Alex provides us that information, I am going to briefly go big face and then go no face because it's time to end the episode because I'm 7 minutes late and I was going to end it earlier and I have not done that. Everyone, thanks for listening audio only. Hopefully that worked. I don't know, but hopefully. Patreon.com/GarethDennis, PayPal.me/GarethDennis, GarethDennis.co.uk/Discord, and GarethDennis.co.uk/merch for Patreon, PayPal, Discord, and Teespring for the merchandise. Next week is going to be a news episode. Tesla is in a mess thanks to its driverless lies. Yes, it's a news episode, and it's a clickbaity title because you mentioned Tesla. A load of maniacs are going to drop into the chat, no doubt, which is fine. Yeah, good. Thanks, Graham, for the. I'm glad you enjoyed the material science. Not a huge amount of detail, but a bit. We talked about fish plates a little bit. Some fun stuff. Lots of research into plastic sleepers. Yes, that's next week, and it only remains for me to go at Big Face. To then click. That was a good episode. I'm glad you enjoyed that. Handheld sticks. Thanks, Alex. Yes, I thought so. It only remains for me to say, cheerio, everyone. It's been an absolute pleasure. Cheerio. Cheerio.